right, today's video lesson is Chapter 3, Lesson 1. We're going to change fractions into decimals. And so my first question is, what does this mean? What does this mean? And what does this mean? They all mean the same thing. Divide, 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 divide. Fractions to decimals. All we have to do is divide. So if I had 7 divided by 8, 7 divided by 8, or 7 divided by 8, they all mean the same thing. Have you ever thought that a fraction just means division? This straight bar is the same as this little house, is the same as 2 dots with the line. 7 divided by 8. That's really how you read it. 7 divided by 8. 7 divided by 8. 7 divided by 8. All means the same thing. So the name of the game today is divide, divide, divide. That's all we have to do. So how do we divide 7 divided by 8? Or what is going to be the answer? What's it going to look like? So I write the fraction, and then I draw the house. And the house has got to be on the bottom floor, because if the house was way up here, it's floating, and that just seems weird. And then I take the top guy, and I bring him in, and I go scribble, scribble, scribble. And that way I know who goes where. Sometimes when it's a fraction, I get confused. Is the 7 in the house, or is the 8 in the house? Who's in the house? Who's the divider? Who's the dividend? And so it just confuses me. So I write it as a fraction. I draw my house on ground level. Now I know my 8's on the outside. The top guy comes in. 8 can't go into 7, so I write a 0. I add a decimal. I add a decimal. I get to add another 0. 8 goes into 70. 8 times, which is 64. 70 minus 64 is 6. Oh, darn. I wanted it to be even. I wanted to be finished. I wanted to be done with this question, but I'm not. So I'm going to add another 0. I think I'll change colors. I'm going to add another 0, and I'm going to bring that 0 down. 8 goes into 60 7 times. 7 times 8 is 56. Subtract and get 4. Oh, shoot. I wanted it to end, but it didn't. So now I got to go again. Add another 0. Bring the 0 down. Oh, 8 can go into 40 exactly 5 times. And I am finished. El finito, done, 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 done. So 7/8, we can't really see it anymore, but 7/8 turns into 0.875, 875 thousandths as a decimal. It's your turn. Change 3/16 into a decimal. Stop the video. See if you are correct. Divide, divide, divide. I got 0.1875. I had to end up going 4 times, but I finally got it to end with a 0 remainder. All right, this next section I like to call in your head. So maybe these are fractions that you can change to decimals in your head because you just know how to do them. You've done this so many times. You know what 1/2 is. Half is 0.5. 1/4 is 0.25. 1/4 of a dollar is 25 cents. What would 3/4 of a dollar be? 0.75. See how many of these other ones you know. Pause the video, and then I'll write them all out. Push play again and see how many that you knew. All right, here's all the answers. So the thirds were 0.3 repeating and 0.6 repeating. The fifths, 0.2, 0.4, 0.6, 0.8. So you kind of just double what's up here on the numerator. If you can say these, you can write them correctly. 1/10. 1/10, 2/10, 2/10, 3/10, 3/10. So if you don't want to divide on these, you still can divide. You'll get the same answer. But if you don't want to divide and you just want to memorize this list, this would be a really good list to just know off the top of your head, these fractions make this decimal. All right, let's talk about repeating decimals. So let's suppose you did some division and you ended up getting a single number, like a 4 and a 4 and a 4, and it just was going to keep going on as 4s. Well, how math people write that is 0.4, and then they put the bar over the 4, but they only write one of these 4s. So even though there's a whole bunch of 4s, they only write one, and the bar goes above. This next example, 4, 2, 4, 2, 4, 2, the chunk that repeats is a 42. So you write 42 and you put a bar over both numbers. Both numbers repeat, 42, 42, 42. This last example, the 4 doesn't repeat, the 1 doesn't repeat, it's only the 6s that repeat. So I would have 0.416 with a bar only over the 6, and I only write one 6. I don't write a bunch of 6s, I just write one. All right, let's talk about comparing numbers, comparing decimal numbers. So my first example, they both have 2 digits, that's nice. So is 21 bigger or is 25 bigger? 25 is bigger, so that means 0.25 is also bigger. 0.25, 25 hundredths is more than 21 hundredths. In this example, this is one the book is going to love to give you. This has 2 digits, this has 1. This looks bigger, 16 looks bigger than 2. But, we need to make them have equal digits. I can add a 0 without changing the number. And now all of a sudden you can see that 20 is bigger than 16. The other way you can look at it is look at the first number past the decimal in the tenths place. 2 tenths, 1 tenth. 2 tenths beats out 1 tenth. Doesn't matter what's back here. But a lot of times students don't want to write that, think about that 0, write the 0, or they don't think about tenths place. They just go, oh, 16 is bigger than it was a 2. Now let's talk about negative numbers. So negative 0.4 and negative 0.5. Well, if I did a number line, I meant to do that in blue. Let's do that in blue. Okay, so this would be negative 0.1, negative 0.2, negative 0.3, negative 0.4, and negative 0.5. Well, in the negative land, you want to be whoever's closer to 0, closer to getting out of the hole, closer to getting to the positive numbers. So between these two people, who is closer to 0? The 4 tenths. When they're both negative, whoever is more to the right, these two guys, negative 0.4 is more to the right than negative 0.5. Negative 0.4 is closer to 0 than negative 0.5. So the book will give you a question like this. Compare 1/4 and 2 tenths. Well, you have to make them both match. Now you could make them both be fractions with common denominators, but that's not my favorite method. My favorite method is to change this guy into a decimal. Remember, we change him by dividing, or we change him by remembering that he's one of those easy ones. He becomes 0.25. So really I'm comparing 0.25 and 0.20, which is similar to what we just did, and 0.25 is going to be larger. So if you have a fraction and a decimal, make them both decimals. Just so much easier. All right, here are your Google Classroom questions. Number 1, name a fraction that you have memorized as a decimal. Something from that list that you don't even have to think about it. You can just change it from fraction to decimal, decimal to fraction. Question 2, if you had to summarize this lesson into one word, what word would it be? Pick a word. What's this lesson about? Who is bigger, 0.8 or 0.25? So type one of those into Google Classroom for your answer. Good luck.